So chemical energetics or energy from the chemical. Question 4A. So in this question 4A, you have to read the initial temperature and you have to read the final temperature, and then the difference will be the maximum temperature rise. So example, here you can see this is 20, 21, 22. So initial temperature is 22. Final temperature is 25. So what is the temperature rise? That's equal to 3. Here initial temperature is 21. Final temperature is 23. The temperature change or rise is 2. Here initial temperature 24. Final temperature is 61. And the temperature change is 37. So you just have to find the temperature change here. And using this, the next part of the question is name the gas given off in experiment 3. That's because lighted splint pop. This is a hydrogen gas. Next page. Page 6, part F. We have to explain the observation in experiment 5. What are the observation in experiment 5? In experiment 5, experiment 4 was repeated. In experiment 5, basically experiment 4 was repeated using 1 gram of iron instead of magnesium. The observations are recorded. The solution turned colorless and brown deposit form. So basically what happened, if you check, originally it was copper sulfate solution. So we have a solution, copper sulfate. This part is actually related to chapter 10, in which you will study the more reactive metal displaces the less reactive metal from its compound. So using 1 gram of iron instead of magnesium. And what we have originally, we have copper 2 sulfate solution. So aqueous copper 2 sulfate solution, it's blue in color. And we add a metal because experiment 4 was repeated using iron instead of magnesium. So we have iron instead of magnesium. As we know, you will learn this reactivity as well. Iron is more reactive than copper. So this iron will displace copper from its compound. So when it will displace copper from its compound, so what is the overall reaction here? So the overall reaction is basically iron added to copper sulfate. Iron will displace this copper because iron is more reactive, so it will form iron sulfate plus copper metal. So this brown deposit is what? The brown deposit is the copper metal. And this iron sulfate is the solution. So the answer for this part, because you have to mention the explain the observation in experiment 5. So basically what we observe in experiment 5, that iron is more reactive, so it will displace the copper and result is a formation of copper metal. So it will displace copper from the solution. Question 4, part D. Draw a label bar chart for the results of experiment 1, 2, 3, 4, 5. So the temperature changes are there. The temperature rise because here the temperature was 22 initial, the final is 25, and the temperature change was 3. Same thing, you worked out the temperature changes, and using these temperature changes, you have to sketch a graph and a bar chart. So this one is a graph, and you have the temperature changes in the previous, then you will make a bar chart. In question number 2, you will burn the nut instead of extracting the oil from them and then burn. Just burn the nuts, because otherwise extracting the oil, how much oil is extracted from each nut will be different. So for a fair comparison, we should have equal masses of all the nuts, and you just burn the nuts instead of burn the extract from the oil or extract from the nuts. Is it clear? Anyone else having a doubt in this exercise? Chemical energetic exercise 1. I'm sharing the answer key also with the homework, so it does not mean that you don't have to submit. You have to submit even answer keys with you. You have to solve, check, and then submit. Because I can check the quality of answer when you're submitting the homework. Anyone else having a doubt in this exercise, chemical energetic? Stirring by the help of a thermometer is not considered as an error. Because what happened? Look, if you are measuring a temperature, I have a container, and this container is having a solution, and I add a metal. A solid metal is added, and because what happened, liquids are not good conductor of heat energy, so when we add, the liquid will not will have a uniform temperature change. So to have a uniform temperature change, what we can have a thermometer, and this thermometer, we can also use this thermometer as a stirrer. What is the advantage of using this thermometer as a stirrer? So that it will be uniform transfer of heat energy. So stirring with the help of thermometer is reducing the error instead of creating an error. Otherwise, what you have to do, you have to use another piece of apparatus, a stirring rod, and stir with the rod. So that stirring rod will also absorb some energy. So it's better you stir with a thermometer, which reduce the error of non-uniform mixing, or error due to non-uniform mixing. Any other doubt in this? If no doubt, then I'll start the topic. So we started this chapter, chemical energetics or energy from the chemical. Practically how a chemical reaction occur. Page 9, part B1 and 2. From your graph, deduce the maximum temperature of a solution if 6 gram of solid S was added to 30 cm cube of distilled water, and show clearly on your grid. So in this case, first you should have a, you should join, means plot a graph. This is how the graph should appear. So what we have to do, from your graph, deduce the maximum temperature of the solution if 6 gram of a solid, and whenever you are sketching a graph, use thin lines. These lines, don't try to rewrite or don't try to make the lines again and again. That's you will lose a mark, because there are 4 marks for plotting this graph, so you will lose 1 mark for thick lines. So always use thin lines to sketch a graph, and points should be visible. So from your graph, deduce the maximum temperature of a solution if 6 gram of solid S was added to 30 cm cube of distilled water. Show clearly how would you work out your answer. So what you have to do, if you check the values, so you have initial temperature and minimum temperature of solution, and you have initial temperature and maximum temperature of a solution. So, and in the question, we need a maximum temperature. So what we will do, we'll continue this graph, extend this graph, and if 6 gram of solid acid added, so you will draw a line from 6 gram. This is a 6 gram. So you will draw a line from 6 grams and then identify what is the temperature change. Is it clear? So, and when they say show clearly on your grids, you have to draw the lines. Like 1 mark is for drawing the lines and 1 mark is for the final answer. And the second part, is from your graph, deduce the minimum temperature of a solution if 4.5 gram of solid T were added to 30 cm cube of distilled water. So how you can identify? You will draw a line from 4.5. So this one is 4.5. So we'll draw a line from 4.5 and identify what is the minimum temperature. Is it clear? The maximum and the minimum temperature, because we need a maximum temperature when we added 6 gram of S, and we need a minimum temperature when we add 4.5 grams of T. Any doubt in this? Okay, chemical energetics, we start. This is a continuation of the topic. So when a chemical reaction, how a chemical reaction occur practically. So example, you have reactants. A and B are the reactants. And when they collide with each other, this leads to a formation of a product C. Example, these are the particles of A and these are the particles of B. So how they react or how they form a product. Example, particles of A having a 10 joules of energy and particle of a B is having a 5 joule of energy. How a reaction occur? Reaction occur by collision. When the particles collide with each other, when the particles hit each other, as a result, they will form a product. So A is reacting with B or A is colliding with B and as a result, it is forming a product C. So what is the energy of the reactant here? If I say A is having a 10 joule of energy and B is having a 5 joule of energy, so energy of the reactant is 15 joules. So what happened? Energy of the reactant is 15 joule and they are colliding with each other, but they are not forming a product. Why they are not forming a product? Because they need a minimum energy for reaction to start. This energy, they have this energy, but this energy is not sufficient to start up the reaction. So what happened? First, the reactant particle absorb energy. So first, the reactant particles is absorb energy from the surrounding. So as the reaction particle absorb energy from the surrounding, the total energy of the particle will increase. Energy is taken in. So when they absorb energy from the surrounding, the total energy of the particle will increase and at certain energy, the reaction start. So energy at which the reaction start is known as activation energy. So in the beginning, the reaction does not start by itself. The reactant must absorb energy from the surrounding. Once the reactant absorb energy from the surrounding, they reach a certain energy for reaction to start. And that minimum energy, energy at which the reaction start, that is known as activation energy. So example, reactants have energy 15 joule, but 15 joule is not an activation energy. Why it is not an activation energy? Because there is no reaction. What happened when the particles were having a 15 joules of energy? These particles will collide with each other and then they bounce back. So example, A and B are the particles. A is having 10 joule of energy and B is having 5 joules of energy. These particles collide, hit each other. When they collide, they bounce back. or rebound. So this is not the activation energy because the particles are colliding, but they're not forming a product. So to form a product, what particles will do, the reactant particle, first they will absorb energy. When the particle will absorb energy, they reach a certain energy where the reaction can start. So example, they reach energy, the energy of A is now, after absorbing the energy of A is now 50 joules, and energy of the B is originally it was 5, now example it is 20. And now when they collide with each other, as a result, they form a new substance. They formed a product C. So what is the total energy of the particle when they're forming a product C? So A is having 20, B is having, A is having 50, B is having 20. So what they will do, they will form a product C, and this energy, the minimum energy for the reaction to start, what we call that as activation energy. So in this example, they reach activation energy, which is 70 joules. And once they will form the product, when the product is formed, the product, because formation of a product give out energy, so energy is given out. So when a chemical reaction occurs, it does not happen in one step. First, the reactant absorb energy, they reach the activation energy, and then they will form the final product. And once the product is formed, because product formation is a bond forming, and bond forming is exothermic. So if I summarize this in steps, so first what happened, how a reaction occur? First, the particles of the reactant gain energy to reach activation energy. A particle of reactant absorb energy, you can write absorb as well, to reach activation energy. That's the first thing which happened. Then what happened? At activation energy, reaction starts and product formed. And the third one, when a product is formed, energy is released, because formation of a product is a bond forming. That's why energy is released. So for every reaction, energy is absorbed. Activation energy is a minimum energy for reaction to start. All the energy, like you have the particles, say you have A and B are the particles. A is having energy of 40 joules, B is having energy of 30 joules. Once they collide with each other, because for formation of a product, they should collide. When they collide with each other, they bounce back. No change. So if particles collide and bounce back, means they don't have activation energy, or it is not an effective collision. But if a reaction, and when a reaction occur, if it result in a formation of a product, like example, you have A and B. So the minimum energy at which the reaction start or reaction occur. So A and B collide with each other, and energy of A is equals to, say, 50 joules. Energy of the B is equals to 40 joules. And when they collide, this result in a formation of a product. So if a product is formed by a collision of the particle, the minimum energy at which the product is formed, that minimum energy is known as activation energy. So this is the activation energy, minimum possible energy for reaction to start. But this is not an activation energy because the particles collide and they rebound or they bounce back. So when a chemical reaction occurs, first energy is absorbed, and when the product form, energy is released. How you can identify whether the overall reaction is exothermic or endothermic? So to identify the nature of reaction, how you can know if energy absorbed is more than energy released, then it will be endo. But if energy released is more than absorbed, then it will be exo. So you have to identify which one is more, either energy released is more or energy absorbed. So whenever a chemical reaction occurs, some of the energy is absorbed, some of the energy is released. You have to check which one is more, energy absorbed is more or energy released. Yes, Hashim, you have a question? Take the screenshot of this, then I'll move on. So example, you have A and B are the reactants, and they're forming a product C. So AB collide and the result is a formation of a C. If I say they absorb, reactant will absorb energy or energy is taken in, they absorb 200 joules of energy. Okay. And when the product is formed, it releases 350 joules of energy is given out. Energy which is taken in is 200, energy which is released is 350. Which reaction is this? Exothermic or endothermic? Energy absorbed is 200 joules, but energy released is 350 joules. Which reaction is this? This is an exothermic reaction. Why? Because energy released or energy given out is more and energy absorbed is less. Only 200 joule of energy absorbed, but as a result, 350 joules of energy is released. So the reaction is exothermic. You can also use your mics to convey the answer. Which particles will have more energy? So the first answer, this is exothermic. Which particles will have more energy, reactant or product? It's an exothermic reaction. Reactant absorb energy and the product is formed and the product release energy. So which particles will have more energy or high energy? Reactant or product? Reactant will have high energy because the reactants are absorbing energy. So reactants are taking energy, that's why they have high energy, and the product will have low energy. Reactant absorb energy and then they will form a product. When the product is formed, the product gives out the energy, so product energy will decrease. Because the reactants are absorbing energy, so their energy will increase. So if we sketch energy diagram for this reaction, so energy diagram for exothermic reactions, so reactant will have high energy and the product will have low energy. Why reactant have more energy? Because reactants are taking the energy. You can see here, reactant absorb or take in 200 joule. So energy of the reactant will increase. But when the product is formed, the product gives out energy, product release energy. So as the product release energy, energy of the product will be less. That's why reactant have high energy and the product is having low energy. So for exothermic reaction, energy of reactant is always higher than energy of the product, the particle energies. Is it clear? For exothermic reaction, so this reaction was exothermic, in which reactants have high energy and the product is having low energy. Take the screenshot. Any doubt in this? Another example, if you have A and B are the reactants and they're forming a product C. So A and B absorb energy, example 100 joule or 200 joules of energy is absorbed by A and B. And when the product is formed, product only release 20 joules of energy. Which reaction is this? Endothermic or exothermic? Energy absorbed is 200, where energy release is only 20. So this reaction is endothermic because energy absorbed is more than. So this reaction is endothermic. That's correct. The second part, which particles will have higher energy, reactant or product? So that because the product is releasing a small amount of energy, reactant absorb 200 and form the product, and product only release 20 joule of energy. So when we sketch a graph, for endothermic reactions, so in this case, the product will have higher amount of energy. And if we sketch an energy diagram for this reaction, the reactants will have low energy and the product will have high energy.